Okay, so yesterday you guys worked on some questions with Mr. Van Ur, some naming practice. There were 2 mistakes at least that were discovered on the key. Okay, and the first one is number 1. This is the very first question. Okay, and I guess I was just in a rush, or it was a typo or something. Okay, but I did screw up number 1, and I believe 41 was the other one. So number 1 is supposed to be calcium, was it phosphide, right? Okay, and I had in the key CAN, and that's not right. It should be Ca3 P2, okay, for that one. Okay, so there's a mistake on the key for that one. I fixed the original of the key, but obviously the one I put into Google Classroom still has the mistakes on it because I haven't switched it yet. Okay, and then number 41, iron 2 fluoride. I think I have iron iodide there. Okay, I think I have FeI2, and it should be FeF2. Okay, so I made a couple of mistakes on the key. Those are the corrections. Okay, how are we doing on those so far? Anyone get past that first page yesterday? Okay. How many people have gotten onto ones that are going from formula to name? Okay. Any ones that were giving us trouble besides the 2 mistakes on the key? Well, what I want to do first to kind of just start things off is I want to just quickly go through kind of like a flow chart thing. This isn't in your notes, so if you want to copy it down, feel free to do so. Okay, you don't have to, but it's just kind of a flow chart to use if we're going to be writing the chemical names. It's a little kind of quicker than reading through the entire notes package to get what you need. So if we are writing chemical names, okay, so if that means we're given the formula and we need to write the name of the chemical. Okay, the first step is to determine whether it is ionic or molecular. Okay, and we determine that by looking for the presence of a metal or a positively charged polyatomic ion. Basically, if ammonium is there, it would be your only exception to that rule. If it's got a metal in it, it's definitely ionic. Okay, so if it has a metal in it, step 2 is write the name of the metal, and then step 3, write the name of the nonmetal. Okay, and then for step number 4, if it's ionic and the polyatomic ion, if there's a polyatomic ion, write the name as it appears in the table. Okay, so if it's like iron nitrate or something, iron 2 nitrate, then I would find nitrate in the table of polyatomic ions and write nitrate. Okay, and the last thing we check for is if the metal has more than one possible charge. So the example I just gave was this, okay, and I'm trying to write the name of that, so I've already done the nitrate part, okay, but iron also has more than one possible charge and requires a Roman numeral, okay. In that case, I look at nitrate to tell me, okay, nitrate's a -1, all right, and there are 2 nitrates, so that means I've got 2 negatives in total, so this must be the iron with the 2+, and then I put the right Roman numeral. Okay, so that's the rules that we go through if we know that it's ionic. Okay, if I get that instead, okay, is that ionic or molecular? It's molecular. Phosphorus and oxygen are both non-metals. Okay, so in that case, I follow the molecular rules. Step 2, for molecular, write the first non-metal name, write the second non-metal name ending in "ide." Okay, so I would write okay, and then place prefixes on names where appropriate. Penta. does anybody still need that slide? Okay, and then going the other way, okay, just kind of a quick kind of flow chart setup of writing the formulas. So if I'm given the name of a compound, so let's say, I'm given that, copper 2 sulfate, okay? First step, is it ionic or molecular?
Ionic.
It's ionic, copper's a metal, okay? And would you ever see a Roman numeral in a molecular compound? Not ever, right? There's no non-metals that have more than one possible charge, okay? So we've got copper 2 sulfate, we know it's ionic, okay? So it says write the metal symbol and its charge, okay? Write the non-metal symbol and its charge, all right. So our non-metal is actually a polyatomic ion, so I would have to go up to the table of polyatomic ions, and I find out that sulfate is -2. Okay? And then I drop and swap. Do I even need to bother dropping and swapping here? Charges already add up to 0. Okay, so there's my formula. Okay, do I need brackets around my polyatomic ion in this case? I only need brackets around it if I have to put another number beside it. So if instead I had this one, this one would need brackets, okay, for this reason. This is the nickel with the 2+ charge, that's what the Roman numeral tells me, and it's with nitrate, which is a -1. So when I drop and swap, I would have to put a 2 here. Well, I don't want to have this say NO32. I want it to say NO3, 2. Okay? Okay, so let's say I get that. Dinitrogen tetrafluoride, ionic or molecular? Molecular. We don't use prefixes in ionic compounds, so they're both nonmetals and there are prefixes. Okay, so I follow my molecular rules, write the symbols for both nonmetals. Nitrogen, fluorine. Okay, using the prefixes, place the appropriate numbers in the formula. What does di stand for? 2. What does tetra stand for?
5.
4. Okay. Everybody all right with that? Molecular ones are pretty easy. Okay, so those are our kind of basic naming rules. Sorry, for naming chemical compounds. Okay, so just one situation here where we might run into like kind of an exceptional circumstance, okay, would be if I had an ionic compound like manganese 4 sulfide. Okay, so I still follow these rules. Okay, I go manganese, Mn, what's the charge on manganese? 4. Okay, and sulfur, which is a -2. Okay, now I drop and swap. When I drop and swap, I get 2 and 4. Okay, now I got 2 and 4 on this compound, and I left it that way. Should I leave this one this way? I should not. Okay? For ionic compounds, because their ratio, their whole number ratio, that thing Galton talked about, is due to their exchanging of electrons, it needs to be put in its lowest terms. I don't need 2 manganese and 4 sulfurs for the electrons to be balanced. This compound actually contains 1 manganese and 2 sulfur. Okay, so ionic compounds need to be reduced if they can be. Okay. Are you all right with that? It doesn't happen very often, but when it does, we need to make sure that we do it, okay? Because, I mean, we could run into it with this situation as well. Okay, if I have Mg, 2 plus, and sulfur, 2 minus, when I drop and swap, I get 2 and 2. Do we write it that way? No, we reduce it, right? It's already balanced. So the lowest terms for it to be balanced are the terms that we should leave it at. You'd be surprised how often I can catch people on a multiple choice question. Okay. All right, any questions on those rules? Okay, how are we feeling about the ones we did yesterday? Doing okay with that? Because today's a short class, I'm gonna pick a few that I want you to do, okay, that I think you haven't got to yet, okay? And then on Monday, we're gonna move on to properties of compounds, lab report expectations, okay? And then we're gonna have a day to work on the pre-lab stuff for our first lab, and I think I have our first lab either Wednesday or Thursday of next week. Okay, so it's coming up fairly quick. Okay? That's the stuff we'll be going over next week. Okay, did anybody get this far? Onto the second page? Okay, nicely done. Anybody get to this sheet? How far?
Well, I like stopped halfway on the first ones and then I switched, so I got to 30.
Okay, all right, let's just pick. Okay, I want you guys to try those 4. All right, we're going to go over those here in a couple of minutes. Okay, word of caution, just walking around, randomly peeking over people's shoulders at their work. Have a look at those first 2. There's quite a few, I'd say probably half of the papers I looked at are missing something in the name of those 2 compounds. Okay, they have the names of the elements right, but there's something missing in both of them. Okay, so what was missing, do you suppose, in the names for the first 2?
The Roman numerals.
Roman numerals, okay? Remember, when we have an ionic compound, one of the things in those rules we just wrote down was put in a Roman numeral if the metal has more than 1 possible charge, okay? So if we're looking at mercury, it can be a +2 or a +1, okay? And the same is true for tin. Tin can be a 2 or a 4, I believe. Yep, 4 or a 2, okay? So we always got to be on the lookout for that, and remember to put that in the names. So for number 31, we should have mercury, okay? And this would be the mercury with the 2+, but I'll show you how I get that in a minute. Chloride. Okay, so I write the names, then I go back here and go, okay, chlorine is a -1, and there are 2 chlorines. That means that this mercury must be a 2+, Roman numeral 2 in the name. Okay, always be on the lookout for that. Same thing happened with tin here, so Sn is tin, fluorine gets changed to fluoride. Okay, fluorine is a -1 charge. -1 times 4 is -4. That means I need to get 4 positives from 1 tin. That means that tin has to have a 4+ charge, tin 4, fluoride. Okay. Now, do you suppose on a quiz or a unit exam, I'm going to pick ones that make you use all the rules? More often than not, yes. Okay? Because if I just, put in a whole bunch, then there's too many questions. okay? I just pick ones where, yeah, I guess they're kind of the harder ones, okay? But they make you use all the rules. They show me that you remember all the rules. All right, for 37 and for 38, okay? So we've got carbon and sulfur. Ionic or molecular? It's molecular. What do I need to do with this? Ide, right? So not sulfuride, sulfide. Okay, and do I need a prefix on carbon? No, it's the first one, so I don't put mono on it. Okay, what do I need on the sulfide? Why?
But there's a 2.
Oh, I thought you meant I should put it. Okay, all right, carbon disulfide. And then for number 38, okay, P stands for phosphorus. Okay, S stands for sulfide. All right, and the prefixes we need, this time we would put a prefix on the first one because it's not mono. Okay, and then for sulfide, penta. Well, I didn't give myself enough room, so. All right, something I want you to do right now. Look at all the ones where you wrote names yesterday. How many did you capitalize? Because remember, these are not proper names and thus should not be capitalized. It was in boldface, italics, I think even, in the notes package. So remember, you do not need to capitalize, nor should you capitalize the names of a chemical compound. All right, questions on those 4? All right, I would like you guys to write the formulas for the 6 that are circled there, please. Okay, let's have a look at these ones. So our first one there, number 5, ionic or molecular? Carson?
Molecular.
It's molecular, okay, both non-metals. So the formula for phosphorus is P, and it's with chlorine, which is Cl, okay? There's no prefix on phosphorus, so we have to assume that it's a 1, okay? And there's a prefix of tri on the chlorine, so we would be looking at PCl3, okay? Good question came up, okay? Just to reiterate, if there is a 1, it is not written, okay? In terms of, like, this I know is a 1 because there's no number here, okay? So if there's no number, it's assumed to be a 1. Any other number gets the actual number. All right, number 8, cobalt 2 nitride, ionic or molecular? Claire, what do you think? It's ionic. Okay, cobalt is a metal. And because it has a Roman numeral there, it's telling me the charge on cobalt is 2. All right, and it's with nitrogen. Nitrogen is always a -3. All right, what do I do with these charges? Swap and drop. Okay, there's my formula. I can't reduce it any lower, okay, so it will stay as CO3N2. All right, number 10, similar. Okay, we've got nickel with a Roman numeral 2, so that'll be an ionic compound, nickel being a metal. Okay, with a 2+ charge, it's with fluorine, which is a -1. Okay, so NiF2. Okay, if you got questions as we go here, guys, don't be afraid to ask. All right, manganese 4 selenamide, ionic or molecular? Ionic, okay, manganese is a metal, so Mn, okay, the Roman numeral tells me it's the manganese that's 4+, and it's with selenium, which is a 2-. All right, so now, when we've got this one, we're going to drop and swap. The 2 is going to go here, the 4 is going to go here, and I'm going to have 2, 4. What do I need to do with those numbers? Reduce. So down to 1 and 2. So MnSE2. Okay, for number 13, I've got oxygen difluoride. Ionic or molecular? Molecular. Okay, so put the O for oxygen. There's no prefix, so that means it's a 1. Fluorine with a 2 beside. All right, and last one, disilicon octachloride. Okay, it's got prefixes, so it's definitely what kind of compound? It's definitely molecular. Okay, so silicon gets a 2, octachloride, O gets an 8. Do I reduce that one? I do not, because it's molecular. Okay, I only reduce the ionic ones because they're about a ratio of electron switching. Okay, if I've got prefixes that say this is a 2 and this is an 8, it's 2 and an 8. Okay, everybody with me there? All right, so I picked all the ones that had little exceptions and little tweaks to the rules that we had to remember.
What did we CL8?
Sorry, chloride. Good eye, Stein. Okay, I don't know why I had oxygen in my head there. All right, everybody okay with those? Making sense? Okay. Okay, I would like you guys to do, yeah, all 6 of those. Okay, and then I'm going to move on to something else. Okay, so we got those 6. We're writing the proper chemical names for those. Okay, well, let's have a look at these ones. So for question number 1, ionic or molecular? Margot, ionic or molecular? It's molecular, yes. Okay, it's got 2 nonmetals. All right, and the numbers are going to tell us what prefixes to use. So 2 is a di-nitrogen, not an M. N. Di-nitrogen. Okay. Trichloride. Okay, everybody good with the first one? All right, for our second one, we've got iron and nitrogen together. Is that going to be ionic or molecular? Read. It's ionic, yeah, okay, iron's a metal. Now, I'm going to write iron, and then I'm going to write nitride, but what does this one need?
Roman numerals.
Needs Roman numerals. Iron has more than one possible charge, 2 or 3. So I've got to look to my non-metal, which has a -3 charge, to tell me what iron is. If they're 1 to 1, iron must be 3 plus. Okay, so we got iron 3 nitride for number 2. Okay, for number 3, I've got calcium and sulfate. So I have a polyatomic ion and a metal, definitely ionic. Okay, so I follow the ionic naming rules. Calcium, sulfate. Do I need a Roman numeral on that one? Do not. Calcium only has 1 possible charge. Okay. All right, the reason I keep asking that is I always see either the rule forgotten entirely, and there's never a Roman numeral, or over-applied, there's always a Roman numeral, okay? So just make sure you're applying it correctly. You only need the Roman numeral when? Right, your metal has more than 1 possible charge, which all you have to do is look at the periodic table. But what starts to happen, it doesn't usually happen as much right away, but it's as people get more confident, and they're like, oh, I remember the symbol for iron, I remember the symbol for manganese, and they stop looking at their periodic table, okay? That's when they stop putting on the Roman numerals, because they're like, well, I know this, and they don't look, and they don't see the 2 charges, okay? So, don't get cocky, okay? It's okay to look at your periodic table, okay? All right, number 4, we got beryllium with bromine. Okay, so is beryllium a metal or a non-metal? It's a metal, so this is an ionic compound. Beryllium. Bromine. Okay, that one's about as easy and basic as they come. No Roman numerals required for that. Okay, for number 7, I've got cobalt and nitrate. Okay, so okay, well, I need a Roman numeral on this one. I will. Cobalt can be a 2 or a 3. So I need to look to my non-metal, which in this case is a polyatomic ion. Nitrate is always a -1 charge. How many nitrates are there? 2. Okay, so I've got 2 negatives. That means this cobalt must have Roman numeral 2 beside it. All right, and the last one, I've got phosphorus and oxygen, okay? That's a molecular compound, so it's just gonna be phosphorus with no prefix because there's no number beside it, okay? Trioxide. Okay, what do you suppose your quiz on Tuesday will be on? Definitely on naming compounds. Okay, there may even be a little bit of stuff from Monday's lesson on there, okay, but it's going to be primarily naming compounds. So if you're struggling with this, make sure you're practicing using the keys that I put on, coming and see me for help if needed. Also next week, we will be in the lab at some point. So a couple of things about the lab and things that you should have with you for the lab. Okay, first off, you learned yesterday that yes, it's okay to wear hats in the school now. Okay, it is not okay to wear them in the lab. All right, so make sure you do not take your hat into the lab. If you have long hair, I recommend putting a hair tie of some kind in your science binder because you will need to tie your hair back when we're doing the lab, okay? There's nothing worse than somebody leans forward, hair gets into acid, and then the whole lab smells like burnt hair. Oh, and your hair looks terrible after that also, okay? But like for the rest of us, it's about the smell of burnt hair. So make sure that you have a hair tie if you have long hair. Okay, also, if you're wearing a hoodie or anything like that, make sure that the drawstrings are either tied up or tucked away because they can also fall into stuff. So, okay, make sure that you basically don't have any loose clothing and footwear. Okay, it's still fairly warm. Lots of people wear sandals or flip-flops or whatever. On a lab day, you need to have a normal pair of shoes. Because if you spill something on the lab table and it goes off the edge and you got bare feet or even soft feet inside of sandals, okay, you're going to get burnt. All right, so make sure you wear proper footwear so you get that extra few seconds to kick it off before it's burning your skin. Okay, so just little lab safety things. Make sure that you have proper footwear, a hair tie, and no loose clothing for the lab. Another thing that often comes up. Listening, please. Okay, eye protection. Anytime we're in the lab, there are goggles in the lab. Glasses by themselves are not sufficient eye protection. All right, so if you normally wear prescription glasses, okay, you will have to wear the bigger goggles that fit over top of them. Okay, they look like you're about to like weld something, except that they're not dark. Okay, or if you have contact lenses and you can wear those on a lab day, then you can wear the smaller lab goggles. Okay, so just be aware that prescription glasses on their own are not safety glasses because stuff can get in through the top or around the bottom. Okay, so they will not be good enough on their own. You'll have to wear something over top of them. Okay, and I will tell you that those big goggles are very old and scratched and hard to see through. Okay, so if you do have contacts, that might be the day to wear them. If not, well, you're just going to have to deal with them being bigger and kind of in the way. Oh, and they leave big marks on your face too. It's great because often this lab happens on picture day, but not this year. Picture day is very late this year, and it's always so funny because it always seems to happen on picture day. People go in and big goggle marks and have 50 days. Not this year because it's the 23rd, I think, picture day, so you don't have to worry about that. Okay, so just keep that stuff in mind. Okay, put a hair tie in your science binder if you have long hair. Okay, that kind of stuff. Remember, guys, that if you're struggling with any of this, okay, lots of times to come in for help or in the flex time, scheduled help, whatever thing that you're voting on the names for. Okay, after period 3, you're also welcome to come and see me during that time, starting next week. Okay. All right, that's it for today.